Electrolysis, decay purification of, we had to do purification of copper. Well, we did electroplating, right? We'll try and recap electroplating, right? Electroplating was that you were going to keep the object that you want to electroplate. So you're going to keep the object that you want to, like your spoon, you're going to keep it at the cathode. And at your anode, you're going to keep the metal which you want to electroplate it with. And the solution should have ions of the electroplating metal. And if you want to electroplate it with copper, the solution must have copper in it. So what happened was at the cathode, electrons would come in and you had copper ions and H+1, and copper ions were the ones that ended up gaining electrons and they turned back into copper. They got reduced. Gain of electron is reduction. And therefore you started seeing a copper metal getting deposited on top of the object. At anode, what happened was the battery was trying to pull electrons. Normally, it would pull electrons out of the ions, OH ions or SO4-2, but if it's made out of a metal, the electroplating metal, it's going to, the metal itself is going to lose electrons. So nothing would happen to OH ions or nothing would happen to SO4-2. The anode itself would lose electrons and copper ions would be formed. So overall, what would happen is that on one side, copper ions are getting formed, and on the other side, copper ions are turning back into copper. So there would be no changes in the solution. But on one side, copper ions are getting formed, and on the other side, copper ions are turning back into copper. So overall, net amount or change in ions would not be there. It's if 10 copper ions are formed, 10 copper ions are turned back into copper. So the net change in the ions will not happen. And therefore, you won't see any changes happening to the solution. Okay, so that was electroplating. So I said, now what we wanted to do was we wanted to learn about purification of copper. So I told you about copper ores, and now copper ores. I say mineral minor. It's mineral. I say it's mineral raw form. I say ore is a mineral raw form. So copper ore, I told you that copper is kind of something that's less reactive. So a lot of times copper is found in the original state. Okay, it's found as a rock, and there's just pure copper inside it, just like gold nuggets. Sometimes it's also found as compounds, and we're going to talk about that as well. Like the first thing is, how do we purify copper? So I told you the rules that if you want to purify copper, so you found a rock which is impure. It has sand in it. It has other minerals in it. So let's say there's this copper. There's a rock, and that rock has copper metal inside it. So what you're going to do is you're going to turn it. You're going to make it the anode. Here, that's the so now that's the positive. So that's the positive terminal. And you will keep your pure copper at the cathode. So over here you're going to have your pure copper. And then obviously all of this is dipped into a container. And since the important here is since you are trying to purify copper, the solution must be made out of copper. It must have something. So you can have copper sulfate aqueous over here. The rest of the stuff is pretty simple. That's your cathode. And this side over here is your anode. The battery is trying to remove electrons. That's the positive side. and that side is my negative side. I've got copper sulfate. So what ions do I have at cathode? It's going to be copper plus 2. SO4 minus 2 ions will be on the other side. I'm going to have H plus 1 and I'm going to have OH ions. Now what happens is that who's going to gain electrons? So between copper and H, it's copper is lower in the reactivity series. So they are the ones that are going to get reduced. They are the ones that will end up with the electrons that are coming from the battery. So the equation over here will be that copper plus 2 would gain 2 electrons and it will turn into neutral copper. And you would start seeing pure copper metal getting deposited on top of this, on top of the cathode. So the electrolysis is pretty simple, just like the way it was happening before. On the other side, who's going to lose electrons to the battery? So remember, I told you, just like in electroplating, the OH ions and the SO4 minus 2 are not the ones that are going to lose electrons. The impure copper is the one that's going to dissolve, and it will lose electrons. So impure copper loses electrons and dissolves, gets oxidized. Okay, the word that's going to be used is that it gets oxidized. So the copper that is inside the ore would start turning into ions and it will start to lose electrons. So it will start turning into ions and you'll start seeing copper plus 2 ions getting formed. So on one side, what's happening is that the battery is removing electrons from the copper that's inside the ore, inside this rock. And when that copper loses electrons, it turns into copper ions. And the solution, so the copper ions in solution, their concentration increases. On the other side, the negative cathode attracts the positive copper ions. This is negative. So it will attract the positive copper ions. And when the electrons come in, copper ions are the ones that are going to gain those electrons back and they will turn back into copper. So what is happening is that copper is getting dissolved on one side, this side. And on the other side, the same copper is going to the other side, getting attracted to it, and it's getting deposited on that side. Okay? So is this thing clear? Fatma, clear? Taha, Zainab, is this clear? Yeah, how
So
copper
you
is
have to
getting.
Yes,
explain the
sir.
last part again.
Yes, sir.
Nizar, क्या question है?
Can you explain the last part? Oxidize हो गया copper anode पे फिर.
So it's what's happening to the copper that's inside? Well, let's say these are the copper metal atoms stuck over here. So they'll lose electrons and they will start dissolving and they'll start forming copper ions, right? Okay, who's taking the electrons? The battery is taking electrons. So the copper atoms that are inside the ore, they start turning into copper ions. So copper ions, they become part of the solution, right? Ye clear hai? The impure copper dissolves. Is that clear?
Yes, sir.
So where would the positive ions get attracted to? They'll get attracted to the negative cathode, right? So all these copper ions, where would they end up? They'll get attracted to the cathode. Well, the battery is sending electrons, so they'll end up gaining electrons back again. So what happens is that the copper ions, they eventually reach the cathode, they gain electrons and they turn back into copper. So in this rock, only the copper ions dissolve. They then travel and get attracted to the cathode where they gain electrons back and they turn back into copper. So this is how copper is getting purified because all the impurities, they remain behind, or mostly they form or they fall in the form of a sludge. But all the rocks, etc., all the sand, that will remain behind. TK, is this clear? Zara
Yes,
clear?
sir.
Okay, बाकी ज़ैनब
So ये last part होगा net issues हैं हमें
अच्छा नहीं लास्ट पार्ट क्या
कि last आपने क्या बोला मेरी screen तो अटक गई है भाई.
अच्छा नहीं, मैं कह रहा था कि देखो कॉपर आयंस डिसॉल्व है ना, ये क्लियर है? कॉपर आयंस आर
यस
गेटिंग
यस
डिसॉल्व्ड.
यस जी.
Where would the copper ions, and why are they getting dissolved? Because the battery is removing electrons, the anode is removing electrons from them, right? Now, where would the copper ions get attracted to? They'll get attracted to the negative cathode. Clear? So they'll all get attracted to the negative cathode. Is that clear?
Yes sir.
What will happen over there? At cathode, the battery gives electrons or sends electrons, right?
Yes sir.
So, so what will happen to them? They'll gain the electrons back and they'll turn back into copper, right?
Yes.
So as a result, what's happening is on one side they're losing electrons and they're turning into ions, and then they get attracted to the other side where they end up gaining electrons and they turn back into copper. So as a result, what is happening is that you're getting pure copper over here. Okay? All the impurities that were in the rock, they remain behind. And only the copper ions they travel and they reach the cathode and they get deposited there. ठीक है Zarar, is this clear?
So what is the sludge?
मतलब वही जो पीछे rock, sand, etc. that will eventually fall back, right?
So sir, basically the impurities.
हाँ, impurities. मैं लिख देता हूँ, that's impurities. Right? Is that clear?
Yes.
Achha, so this is how copper is purified. You can remember this is a very this comes in P6 as well. Especially the last question in P6, which is a 6 mark question. They might ask you to explain how you purify copper. Okay, you're going to draw the whole diagram. You're going to write the equations. You're going to tell them that the copper anode is dissolving and the copper is getting deposited at the cathode. I say, anyways, so this is what happens when you have copper in the form. Remember, copper ore is in two forms. It can either be in the form of in its original state, like in the form of copper. But what if copper is in the form of a compound? Okay, last time I showed you rocks. They were green colored rocks. Matlab, you see marble. I mean, a lot of marble, like the blue colored marble, it's got copper in it. Copper sulfate is blue colored. Copper carbonate is green. So whenever you see green marble has it probably has copper carbonate inside it. So sometimes, so the next thing is, how would you extract copper if it's in the form of a compound? So, copper extraction,
So the last one would be called as copper extraction from the its ore.
if ore has, instead of pure copper, it has copper compounds.
Then the last one, the ore had the pure copper.
The ore had pure copper. No? Matlab, last time, let me just show you once more. Okay, replace current share. 1 second. Screen. मैच का क्या हुआ है?
So 10846. अभी चक्का मारा है नवाज में.
पालेगा है फिर ये सब. अच्छा, 1 second. क्या प्योर कॉपर ओर. ठीक है, तो remember, so I'm just going to show the images again. I just remember I told you that copper can either be in the form of like original copper inside the rock. ठीक है? So over here you don't have to do a chemical reaction. You just have to purify it so that the copper over here dissolves. You're going to make it the anode and it gets deposited at the other side. But sometimes copper would also be in the form of a compound. So copper carbonate is green, copper sulfate is blue. So it can be in the form of a compound as well. ठीक है? Is that clear? So right now, what we're going to do is
Yes, sir.
the next extraction that we're going to do is, just 1 second, let me share the screen. अच्छा, so कहाँ गया? यार है नजर. ठीक है. So now the next extraction that we're going to do is what if the ore has copper carbonate and maybe copper sulfate in it? This is your rock, and remember it's a P6 question mostly. So the step number one is you're going to dissolve it. ठीक है, step one is dissolve the ore in concentrated sulfuric acid. And so what's going to happen is that this copper carbonate would react with sulfuric acid. If you know the equation, the carbonate plus acid is, it's going to produce salt, which is going to be copper sulfate plus water plus carbon dioxide. Copper carbonate, remember, was insoluble. If you remember the solubility table, all carbonates were insoluble except for group 1. So when you dissolve it in acid, it forms copper sulfate. All sulfates are soluble except for 4,5 sulfates. So it forms copper sulfate is blue in color. It's a blue solution. So what you're going to do is you're going to dissolve the copper carbonate and or a mixture of copper carbonate and copper sulfate. And let me draw a beaker over here. So it has, let's say the beaker has H2SO4. Let me make the ore smaller. 1 second. So you're gonna just put it inside the sulfuric acid until it dissolves. And step number 2 is that you do electrolysis. So step 2 is electrolysis of copper sulfate aqueous. Okay, which we've already done. But I'm just going to do it very quickly once more. There's going to be an inert, a graphite cathode and a graphite anode. And they'll be connected to the battery. So this is the positive terminal, that's the negative terminal. So they're connected to the battery. You've got negative cathode. And you've got positive anode. And there's a beaker. So now your ore has dissolved. There's one thing, once you have, step 2 is, step 1 is dissolve the ore in concentrated sulfuric acid and then filter the mixture as well. So that all the impurities, the solid sand, etc., they get filtered out. Filtration will carry 1 mark. Okay, so once you get your copper sulfate aqueous, you're going to filter the mixture so that all the rocks and impurities, they get filtered out. And then you have copper sulfate, you just do electrolysis. So there's copper sulfate, pure copper sulfate aqueous, and the rest we've already done. The copper ions, they get attracted to the cathode sulfate. You've got H+1 and you've got OH-1. Make sure you're using graphite anodes, which is inert. And this one is also going to be made out of graphite. And the equation is simple. The copper ions are the ones that are going to gain electrons coming from the battery. So they're the ones that gain electrons and they form copper, and you see pure copper getting deposited at the cathode. And at anode, remember the rule was that it's always going to be OH ions. This time you're using inert electrodes. So the rule was at anode was it's always OH ions, except if halides are concentrated. So the equation for OH ions is that it's 4 OH ions and they lose electrons and they form 2H2O plus O2 plus 4 electrons. And you see bubbles of O2 gas. TK, we've done that plenty of times. And you see a pink, shiny metallic deposit. TK, so remember two steps. If the ore of copper is in the form of copper carbonate or some copper compound, you're going to mix it in acid. You're going to make sure that it dissolves. You will filter the mixture so that all the impurities are removed. And then you will just do the electrolysis. So it will just be the electrolysis of copper sulfate aqueous. Okay? ये clear? Is this clear to everyone? The is this clear? Hania clear? Shanzeh, Rar,
Okay.
here. Okay. So that's it. I said now, so we kind of pretty much done with, we did electroplating, we did uh, this thing as well, which is purification of copper. Now, there is one other thing, one other electrolysis, which we have to do metals after this chapter. We'll do metals in the reactory series. So we'll actually do that in that chapter. Okay, that is the extraction of aluminium. Well, I'm going to write this down. That extraction of aluminium, that's a very detailed process. So, so I'm just going to write that this is going to be in the next chapter. Okay, but that is electrolysis as well. Now, the last part of the chapter, that's electrolysis, is all done. After this, once we are done, we'll do past paper questions. A lot of the past paper questions would be about copper sulfate electrolysis. Now, the very last part of the chapter is that, I mean, there are actually two parts left. We have to do redox reactions and we have to do cells. So, what are cells? Cells, as I remember, electrolysis is done. Electrolysis was the decomposition of an electrolyte by passing current. Cells are actually the exact opposite of they're the exact opposite of electrolysis. What happened in electrolysis was that you had a battery. So basically you had electrical energy. And because of that electric energy, a chemical reaction would happen. So that electrical energy got converted into chemical energy. I mean, basically, if you look at electrolysis over here, why did copper gain electrons? So why did copper ions gain electrons? The reason it gained electrons was because there was a battery that was forcing electrons down its throat. Okay, if the battery was not sending electrons, copper ions would not be able to gain electrons. So the point is that there was electrical energy, there were electrons flowing, and because of that, that led to a chemical reaction. Copper ions had to gain electrons. The same on the other side as well. Why did OH ions lose electrons? Well, they had they didn't want to lose electrons. It was the battery that was pulling electrons out of it. So, so there was already an electric current, and that electrical energy got converted into chemical energy. Okay, now, so that's electrolysis. But on the other hand, an electrochemical, I mean, the exact word is electrochemical cell. In that, what happens is that there's a chemical reaction that's going to take place. And because of that chemical reaction, electrical energy gets produced. I mean, that's how most of your cells work. I mean, if you have a UPS battery or if you have a remote cell, there's a chemical reaction that's going to happen in the cell. And because of that chemical reaction, an electric current gets produced. So it's exactly the opposite. Uh, so remember, electrochemical cells are the exact opposite of electrolysis. These are also known as galvanic cells. So we're going to do the first one. The first one is your hydrogen oxygen fuel cell. So I'm going to write. So there's going to be a chemical reaction, and because of that, current is going to get produced. Now about the hydrogen oxygen fuel cell, first thing is it's used in rockets. I said, but it's also now used in a lot of hybrid cars as well. I mean, they're hydrogen powered cars. मैं देख लेता हूँ कौन सी car, which cars actually use this. I mean, currently they're actually electric vehicles. They're known as FCEV, fuel cell electric vehicle. I mean, you've got EV cars, and wherever you hear the term FCEV, that's a hydrogen oxygen fuel cell powered car. Uh, Plenty of cars are actually using hydrogen oxygen fuel cells now. Normally, they were used in rockets, in the space station, etc. Okay, so your space station uses this fuel cell to produce electric current. Okay, now plenty of cars are using that. So electric vehicles, they're also using this. I say, anyways, but a few advantages and disadvantages. The advantages are that it's clean and pollution free. Uh, Water is the only byproduct. So very clean, plus it's renewable as well. Renewable means that hydrogen and oxygen, you can easily get hydrogen and oxygen. Actually, Spinner, there was actually a thing added in your syllabus. Let me just quickly check one thing in your syllabus. Just one second. There was one thing that I remember about hydrogen. I said it's renewable. Where do you get oxygen? Oxygen can be obtained. There are two raw materials. So the raw materials are. I mean, renewable means that you can easily obtain them, and the earth is not running out of them. So there's oxygen. How do you get oxygen? Oxygen can be obtained from fractional distillation of liquid air. 21% of the atmosphere. That is oxygen. So fractional distillation of liquid air. अच्छा वो hydrogen के ऊपर I just have to let me just search the syllabus quickly. Hydrogen oxygen fuel cell. That's just give me 1 second. अच्छा नहीं मुझे नहीं मिल रहा, but I'll talk about it in the next class. अच्छा, I'm going to talk about hydrogen. Hydrogen is present in a lot of things. So you can obtain it from oil, and you can also obtain it from electrolysis of by electrolysis, like H+1 and OH ions. We did a lot of electrolysis, and there was a lot of hydrogen getting formed in a number of places. So the raw materials are renewable. Those are the advantages of using a hydrogen oxide fuel cell, and there are some disadvantages as well. The disadvantages are that it's very expensive, and the other disadvantage is that it's difficult to store gases. I mean, gases. I mean, if you've seen any gas like gas. I mean, the fuel that you use in your refinery gases, okay, for domestic heating, they have to be stored under high pressure, which can be dangerous. So it's difficult to store gases. So those are a couple of disadvantages. I say, anyways, so far we haven't yet studied what a hydrogen oxide fuel cell is. Now it kind of looks like this. There's going to be, I mean, the simplest version of a hydrogen oxide fuel cell is that there are going to be two gas jars, and those gas jars, one of them is going to have oxygen in it, and the other one is going to have hydrogen in it. So I've got these two. So I've got these two gas jars. So there's oxygen over here, and let me. Okay, this is the inlet. Okay, so we're gonna put one on this side as well, and we will just 1 second. Okay, that looks better. Anyways, those are your gas jars. And inside those gas jars, there's going to be platinum electrodes that are going to be placed inside it. Okay, so I have platinum electrodes. So these are inert electrodes, and they are placed in both the gas jars.
Sir, inert electrodes will always be made by graphite.
Graphite or platinum. In this case, it's platinum. Okay, so these are your platinum electrodes. You get this one. Both of them are platinum electrodes. So there's oxygen gas that's coming from one side, and there is hydrogen gas that is coming from the other side. Okay, that's being pumped from the other side. As I remember, in a fuel cell, there's going to be a reaction first, and because of that reaction, a current is going to be produced. I said the outer wires are connected together. So one wire goes and connects with the other one, and then let's say there's a voltmeter that's measuring the current that's going to flow eventually. Okay, so there's going to be a reaction first. There is, there's an electrolyte that's added, Now that electrolyte could be a dilute acid or a dilute alkali. It could be dilute H2SO4, it could be dilute NaOH as well. But whatever it is, it's got H plus 1 and OH ions. It's got lots of ions in the solution. It's not UPS like your UPS battery, right? You have to add an electrolyte to it. So this is what your fuel cell would look like. Uh, so how would the electrons flow? How would the current flow in this? Uh, so on one side, what's going to happen is, remember, there's going to be a chemical reaction first. On one side, the reaction is that the hydrogen comes in, reacts with two OH ions, which are in the solution. Okay, so imagine these hydrogen gas molecules coming in, and they eventually react with the ions that are in the solution. So hydrogen is going to come in, it's going to react with the OH ions, and it would form two water molecules, and it will release two electrons. Okay, so you have a reaction on one side, and that reaction, the good thing about the reaction is that it produces electrons or releases electrons. Similarly, the other side, oxygen gas comes in, and that oxygen gas reacts with the ions that are in the solution. So the reaction that happens on the other side is that oxygen gas comes in, reacts with the water molecules, gains 4 electrons, and forms 4 OH minus 1 ions. So the oxygen gas undergoes a reaction and it gains electrons. Okay, so you've got two gas jars, one on the right side, one on the left side. On one side, electrons are being produced, and on the other side, electrons are being gained. On the hydrogen side, electrons are being produced, so you're going to have more electrons eventually on the right side. Is this clear? And the left side is where there's a reaction that's happening and the electrons are getting consumed. The oxygen gas is eating up electrons. So there are going to be fewer electrons on the other side. So what will happen is that a positive charge will build up on the left side because oxygen is going to take up or remove all the electrons. You can remember oxygen is trying to gain electrons. So oxygen is going to use up all the electrons, and this side there's going to be very few electrons. So this side will be positive, and the other side will become negative. Is this clear to everyone? Okay, I'm going to, and remember, you don't have to you have to basically memorize this that what a hydrogen oxygen fuel cell is. There's a reaction that's happening on this side, and during that reaction, electrons they get produced. So your right side has a lot of electrons getting produced. I mean, the reaction, whatever the reaction is, it is constantly producing electrons. And on the other side, if you look at oxygen, there's a reaction that's happening, and the oxygen is gaining electrons. It's consuming all the electrons. So this side over here, all the electrons are going to be used up by the oxygen, and it's going to have a positive charge because all the electrons would be gone. So two reactions happening. One side produces electrons, the other side consumes electrons. ये clear है? Zainab, Hania, Nabila, is this clear? बाकियों
जी
clear है here?
सर।
Is this? अच्छा, so if there's a wire that's connecting the two, what will happen? Electrons will flow from one side and they'll flow to the other side. But on one side there are more electrons, on the other side there are fewer electrons. So a constant current would flow. And that's how current gets produced. That's how your remote batteries work. So on the outside, there will be electrons that will be flowing in the wire. Okay? So just remember that's what hydrogen oxygen fuel cell is. And you have to keep this simple. You need to have an idea that there's hydrogen gas on one side, there's oxygen gas on the other side. There are some random ions that are part of the solution. It could be dilute acid or dilute alkali, as long as there are ions over there. Hydrogen gas comes in. So this, remembering this equation is important. So you just have to memorize this. Hydrogen gas comes in and starts producing electrons. On the other side, oxygen gas comes in, starts reacting with the water molecule, starts removing or consuming electrons. So this side becomes positively charged, that side becomes negatively charged, and electrons would start flowing from right to left. ठीक है? ये clear है? Is this clear? So
Yes, sir.
इसके I'll send you the notes of this. Remember, the more important thing about the fuel cell is you should know the disadvantages. That it's expensive, it's difficult to store gases. The advantage is that it's clean and pollution free. Water is the only product. Plus, it's renewable as well. Who uses is electric vehicles, space stations, rockets. They use hydrogen oxygen fuel cells. ठीक है? So ठीक है, let's continue tomorrow then. ठीक है? Okay, everyone. Take care. Allah Hafiz.